Thanks for joining us here at our IoT session. Before we start, quick introduction. My name is Brian. I'm a Principal Director at Accenture. I'm happy to walk you through our case study with Deutsche Bahn. Before we start, maybe a quick question to the audience. Who of you has an IoT background, roughly? Okay, quite a lot. Who's from North America? Continental Europe? Asia Pacific? Wow, thanks for joining us. So as you can see, IoT is a hot topic around the world. It's a tremendous growth opportunity. We have many client discussions on IoT, identifying business opportunities in improving efficiencies throughout the value chains, in developing new products and new services, coming from product to service industries, monetizing data. It's a complete set of new market opportunity, which our clients are exploiting. Quite interestingly, a lot of clients are in a kind of tipping point from a maturity perspective, coming from a concept and strategy definition phase of IoT towards kind of piloting and POC mode. A few of our clients now reaching a kind of consolidation phase, where they really need to scale it up and industrialize IoT activities. And that's quite interesting, how to do that and how to move forward with that kind of IoT business and activities. In our kind of many C-level discussions we are seeing around the globe, I typically see three common themes in the discussions. From our perspective, the IoT market is a highly custom and highly specific situation for each and every customer. There's no kind of plug and play out of the box capability you just give them and they are starting right away. So there's always a kind of certain level of customization required in our client's ecosystem in terms of having their OT IT legacy, in terms of customizing the vertical use cases, customizing the propositions, and kind of identifying how to perfectly fit into our clients' processes and activities. Secondly, you really need to be agile and fast in these days. You need to kind of scale up and scale down depending on market demand. So there's some kind of flexibility required and some kind of more industrialized delivery capability required in the background to succeed in the market. And last but not least, we see a lot of clients coming from a POC pilot mode in a rather larger rollout situation that really requires different capabilities. While you have been focusing on POCs and pilot with a few niche players, maybe with a few very experienced, very skilled people on the ground, you now need to really have a kind of industrialized delivery setup. And that was kind of a reason why we thought it would make sense to set up what we call an IoT factory in our global delivery capabilities. So how does it look like? So what we have done, and maybe a bit of context of what Accenture is doing together with Splunk. You might know that Accenture is one of the largest Splunk providers in the world. We have more than 4,000 certified people delivering Splunk capabilities for our clients. We have a kind of global delivery network delivering implementation work, use case design, and capabilities for our clients. And what we have done, we have set up a dedicated Splunk IoT center in our nearshore centers in continental Europe, namely Bratislava, where we have set up a dedicated team delivering IoT at scale and with a kind of extended workbench of more than 1,000 FTE with functional and vertical expertise, which can be combined according to our client needs and deliver IoT capabilities. So with that specific knowledge, we would like to walk you through a case study, how we did that and why did we do that and how it could look like also kind of in your context and situation. So let's start with a quick case study. Imagine a railway company with more than 90,000 freight cars. Imagine more than 2,700 locomotives across continental Europe, one of the largest railway and transportation companies. And imagine all the sensor data you have in the field, be it GPS data, be it temperature, humidity, be it any kind of shock information. So a lot of data to be ingested, a lot of value to be addressed and untapped. And that's what our starting situation was with Deutsche Bahn Cargo roughly 2 years ago. And we would like to walk you through a couple of use cases and case studies which we have developed with Deutsche Bahn. And Maros, please take over and walk you through.
Okay, good afternoon also from my side. My name is Maros Mraz. I'm a senior manager in Accenture Digital, and my focus is delivering large-scale IoT and big data projects. So Brian already explained the client situation. So they have a lot of assets they have, and a lot of possible data they can gather from these assets. And because the Deutsche Bahn is quite a major company, and they don't only have these freight cars and DB Cargo, but they have also other subsidiaries like for passenger trains and so on. They decided to create a lab where they bundle those capabilities regarding IoT. It's called Inspire, and they have a dedicated team of 60 to 70 people that they are interdisciplinary teams. So they have people like engineers, they have people from operations, from dispatchers and so on, but they have also data scientists, developers, and they try to create value out of this data. The major goals of this lab is to improve the availability of the assets whilst reducing the cost that the assets are doing. So basically, that's the push is toward the condition-based maintenance, predictive maintenance, to automate and operations, and to give the people more insight so they can do better decisions. And improve efficiency of the company. As you can see, Deutsche Bahn has a lot of assets, a lot of use cases they can implement, and the question was how they can scale these operations. They created a lot of POCs. They had also an on-site team that they were delivering team, but the new projects are starting to be evolving, and there was quickly clear that they need more capacity to implement those use cases. So we work together with Deutsche Bahn, or DB Cargo specifically, and we created this delivery model that consists of 3 parts. The first part is the one which we are already using before, so it's on-site team in our lab, where the client is giving us the insight from the operations, how the operations inside. They have also some engineers and so on, with some consultants from us that they are implementing those ideas or gather those ideas, prioritize those ideas. But what we need to do is to increase our delivery capacity. So with our nearshore model, we choose Bratislava, as Brian said. We had to set up a team that there was specific Splunk resources that they were delivering those use cases. We had also they were also doing designs. They had technical experts, tester, and so on. So they were focusing on the delivery, on the on-site. They were focusing on creating describing those use cases, gathering the requirements, and of course clarifying with the end customers. What we also involved was Splunk professional services, because we want to not only increase the capacity, but we want to also improve the quality and maintain the high quality. That's why we decided with the client that we also involve Splunk capacity services for QA reasons, to get the best practices and so on. So basically, when we started with an idea, this is usually coming from our lab. Our people are speaking with the organization and gathering these ideas. When we have those ideas, we do a prioritization to see which use cases we want to implement first. So we make kind of a short list, and we put them into the backlog where we then in agile and development we are working on them. So in the concept phase, all 3 parties are involved. So nearshore, on-site, and also Splunk professional services. Splunk professional services is there to ensure that we are doing this according to the best practices. They can give us some ideas. They see also what the other clients did. So they're bringing this know-how to the team. Nearshore Delivery Center, they are creating the concept. so we have a first rough idea, we have the estimates, and we know how much the implementation would cost. When this phase is finished, we go into so-called wireframe phase. So we create prototypes, wireframes, where we can test also with the end customers to see how these use cases are perceived. Can we achieve intended goals? They also give us some ideas if there's something to improve or change, and then we are going to design, visual design, and final implementation. The implementation is done from nearshore with support of Splunk professional services. We're using the Splunk professional services especially for code checks, ensure quality, and so on. And this model is quite successful. We started last year in October, and our team already doubled in this time. And we can see also that the quality is very high, and the efficiency of the team is really working up. At the beginning, we needed more Splunk professional services support, but over the time, the support is being reduced, but we still have them on board. Maybe just a quick look on the architecture. As we said, Deutsche Bahn has a lot of assets, different type of assets. They are connected through different providers. So Deutsche Bahn decided that they want to create a so-called asset intelligence center when this data will be stored together. It's going through several layers. First one is the layer when the data is received from the third parties or from the telematic boxes, or it's pulled. Then it's processed, and of course we're using these action rules to distribute the data to data buckets where needed to be. For our Splunk, of course, the real-time use cases are especially in focus. So we are putting them into real-time stream, and we are using these use cases to improve the operational efficiency, to see when the specific maintenance has to be done, and so on. So for the use cases that requires real-time operational intelligence. We brought you 5 use cases, which is just an example of what we implemented so far. We have 2 major things in the focus. First are the freight cars, wagons, and the second one are the locomotives. So the first use case which we have here it's called wagon data quality. So basically, what we want to make sure is that the data which we are receiving is in a good quality, so we can use it also for the other use cases. We can also use this to ensure that the SLAs which we have with the third providers are met. So basically, what we are doing here, we are checking if the data are coming in the specific rate which we are expecting, and we are doing some basic and more advanced check if the quality of the data is correct. This could be if the temperature, for example, is in a certain range of GPS data is valid, or we can do more advanced checks to see if when the for example freight car is moving, there should be also GPS which is changing. So basically, this kind of checks what we can do, and this can enable us to see if the information which we are receiving is valid. The second use case, Wagon Shock Detector. I will come closer to the next slide, so I'll skip it here. Then we have a wagon intelligence, wagon life cycle. So what we want to achieve here, there are two major things. First is to see what is the health of the asset, so to assess the condition of the freight car. And the second one, we are gathering a lot of data. We have a lot of assets, and we can imagine when you want to roll out telematic boxes to 100,000 assets. You need to also manage to see how many already equipped are descending. So all this information that can support you in a rollout phase. So basically, this is regarding the wagon life cycle. The same what we're doing for freight cars, we're doing also for locomotives. complexity is a little bit different. We don't have that many assets, so it's just 2,700. But locomotive are sending much more various data. So when freight car is sending maybe 10 different information, locomotive can send thousands of them. So different temperatures, RPMs for engines, or some pressures and so on. So you have to also make sure that the data which you are getting are correct and they're making sense. So we also established this dashboard where we can check the data quality and also make sure that when the information does not fit, or we need to really create actions to remove the problem. Because we use also this data for maintenance purposes, and of course when the data is not coming in the quality which we need, the maintenance measures might not be sufficient. And the fifth use case which we have here is locomotive workshops. So basically this is around how we improve the efficiency of the workshops, and I will come to this in the next slides. So here's a deep dive for Wagon Shock Detector. So basically what the issue was is that the wagons or the freight cars are usually at a customer. So they, for example, load them, and sometimes they are coming back into bad shape, and you cannot see where the problem happened. Is it something which was already there before it was sent to the customer, or is the problem new? And basically, when you have a shock detector, you can see where the freight car had a stress. For example, this happens if they have a scrap metal and they want to push as much scrap metal into wagon as possible, so they push a little bit hard. And what can happen is that the walls of the wagons are getting damaged, or this can also happen that the axle or the wheels are damaged, or even the wagon can be derailed. So basically, when you see these issues, you can act upon it. And you can ask the customer to pay for the damages, of course. The other things which you can do is this does not happen too often, but sometimes it can happen that the freight car derails, and if you don't see it at the moment, and you of course pull the car further, it can happen that your infrastructure, your rails gets damaged, and this also has quite an impact on your operations, and it's also quite costly. The next thing which you can see also, because the shock sensor can also see what kind of direction the shock has. You can also check part of your components. For example, the buffers which are between the freight cars. You can see based on the impact. Are the buffers working well? So when you are shunting on, so you can see how much is buffer working. So you can also assess first of all, you can assess the condition of the buffers, and you can also give some hints to the local driver, so he should be maybe a little more careful with the assets. And the third thing which you can also see is when the freight cars are, of course, moving throughout the Germany or Europe. You can also see if you have maybe some infrastructure problems. So if you have at certain point in your infrastructure more shocks than you would expect, for example on a bridge, or your rails are not the best shape, you can also see it in your sensor data, and we can visualize those on a map. And of course, you can choose on specific wagons, or you can see a specific part of the place to see where exactly the problems are. The next use case which we want to show you, it's for wagons, for the locomotives, and especially for the workshop manager. So basically, the problem was that as they used to work in the past, was that they get some schedule when the locomotive should come to the workshop, and they had to rely on this information. So basically, they didn't have any real-time information where the locomotive is placed on at the moment, or in which condition the locomotive is. This, of course, leads to quite inefficiencies because when they have a schedule and they create a schedule who is going to repair which locomotive and the locomotive is not there, that's of course not optimal. Therefore, the workshop manager can look at right now where the locomotives are, so he can see which locomotives are planned to be in a workshop. They can see where they are located, and when they are handed over to workshop, they can also see where in a yard they are located. This was sometimes also a problem because during the handover, this was not clearly specified where the locomotive is, and then of course they have to look for it. This time can be also obviously reduced. And what is also quite important is they can also see the condition of the locomotive. So basically, when the locomotives in the past, when locomotives came, they came with the locomotive with a computer and they read out the logs and the diagnosis messages, and then they could take the right measures. Nowadays, with the data which they are getting from the locomotives, this is possible to be done remotely up front, so they can have they can diagnose the problems with the locomotive up front, and they can say the right guy with the right spare parts to the locomotive, further decreasing the time needed to repair and increasing the efficiency of the locomotives.
So thanks for the use cases, Maros. Just to kind of wrap it up. I mean, as you have seen, there are lots of use cases, lots of vertical kind of topics you can do with IoT, and from our perspective, it's always quite important to have the value focus at the cornerstone of the discussion with our clients. The business cases are quite obvious, be it predictive maintenance, be it kind of wagon transparency, be it any kind of monitoring solutions. What we always try to do is kind of to put a clear business in case before kind of starting a larger industrialized rollout. We believe that kind of our factory setup is the right topic to proceed with in a kind of market where we come from pilot to large-scale rollouts. So we are quite happy with the capabilities developed in our nearshore centers. And yeah, I'm looking forward to the discussions with you on kind of your requirements. I think we still have some time for questions, and yeah. Let's open now the audience for questions, and if you have a kind of request, we can also find out at our booth later. Thanks.
Yes, I mean, we are happy to answer your questions. We have also a client that couldn't be here today, unfortunately. But if you have any questions regarding IoT and how to bring the IoT at scale, you can also approach Fabian. He is ready to answer your question. And if you want to also exchange yourself about how to set up a lab or want to use the knowledge which you're already creating in the lab regarding the asset management for rolling stock, he's also happy to answer this.
Thanks, Maros. Any immediate questions? Can you use the mic, maybe?
Hello? You've got a lot of sensors out in the field, and how do you know that the data coming from them is true? That your sensors haven't been tampered with, that your communications hasn't been somehow compromised? Was there anything that you did on the Splunk side to kind of do validation of the data?
I mean, we are, as we explained, we are trying to validate the data. So it could be that when you have, for example, temperature sensors, you see the temperature is jumping up or down. This could, for example, be because when the sensor has the contact is not very well or is detached from the component. So we have some specific checks that we are performing if the sensors are viable for us, because obviously this could lead to a mixed diagnosis. What we can also do is this is also quite often the locomotive is saying we have a problem with the engine temperature. And then you can look at the sensor of the temperature of the motor, and then you can see, or the engine, and you can evaluate is this message valid or not. What was the temperature over the time? So is it, for example, rapidly changing, or it's changing continuously as you would expect? So you can perform some additional checks, which can also save you maybe the visit in a workshop, because you can locate, okay, the sensor is the problem and not the engine itself. So this can also help you in your decisions. But there is no overall solution that you can check all sensors. You have to go over specifically into each one of them and to think what is the purpose of the sensor, what we are measuring, and create specific rule that they can help you resolve the issues. Any other questions?
I have a question about how are you ensuring that people take action on the visuals that are displayed on the dashboard when a problem is detected?
It's a very good question. I mean, this, of course, is a question of change management. How do you prepare your people for new things? Because we are also working with an aging workforce. They're doing this in 50 years in a specific way, and now we have to convince them that this is the right solution for them. So of course you have to motivate them somehow. I mean, what we definitely try to do is to involve them very early in the process and to get also their buy-in before we implement this. I mean, this was also our learning from the beginning. If you don't involve them early, they will not support it, and there will be certain resistance which you have to then go through. So it's easier to involve them early. That's why we are ideating with them, and that's why we are also creating first prototypes before we implement them. They have a feeling then that they can also shape the solution, and they take it for them all. But of course you have a lot of people in an organization, and not all are supportive. So it takes a lot of energy to convince them and to change them into the new processes.
Maybe to add a few words, because that's a great question. Typically, we try to not only develop a piece of software, a capability of technology. So we typically try to join forces with kind of consulting units, with kind of my strategy team, with kind of Marash team, who's delivering the capability and trying to support our clients on a journey of kind of digital integration and digital transformation, which always includes some kind of change management. And very early in the process also kind of integrates different client teams in shaping the proposition and defining the concept and defining the use case. So you have that kind of commitment from the very beginning, and I think that's key from our experience to really deliver the value on the business case.
And you have to do it throughout the whole organization, from the top to the bottom, because if especially in the large organization, if not everybody is on board, then we will have really a hard time. So of course we need to convince the management that this is the right way to do it. There's clear benefits on the end, and they have to also create some pressure on levels below. But you also have to get people on board, otherwise it will not work. Any other questions?
So thanks for joining us. We are happy to continue the discussion. Please visit our booth downstairs. It's kind of the big one where you walk through, and happy to follow up with you on the discussions. Thanks.
Thank you.